All right, let's get into talking about what waves are in the first place. So this is standard W2. And the first thing I want you to know about this is what a wave actually is. We talked about oscillations last time, a disturbance that's happening back and forth. When we talk about waves, waves are oscillations that move away from wherever they start. So if you drop something into the water, say you drop a piece of wood in the wood would bob up and down on the water itself. But the disturbance that they make in the water would move out from the origin. A wave would develop and spread out from that section. So when we talk about oscillations, waves are oscillations. They're just oscillations that are moving through something. When we talk about waves, the one thing that's extremely important here in physics to understand about waves is that waves transfer energy with their motion, right? So if we start a wave at one point, that oscillation is moving from one spot to another spot. It's a wave, and what it's taking with you is the energy itself. So waves are energy transfers. When a wave moves through something, it disturbs what it's moving through. And the matter it disturbs, take for instance the surface of water that has a wave going through it. The surface of the water is there before and after the wave moves through it. However, while the wave is moving through, the water either dips below its normal surface or above its normal surface. The matter itself is disturbed, but the matter itself is not moved. Waves can be coming onto the ocean again, one after another, but they stop at the ocean. The water really isn't moving up onto the beach. It's just moving up the beach, down the beach, up the beach, down the beach. The water's higher, it's lower. The matter is disturbed, but it's not moved. And I want to just take a little second here to talk about optical waves, aka light. Those carry energy as well, but it's electromagnetic energy. I want to give a term for the movement of a wave because when we talk about things moving, movement means matter going from one spot to another spot. Since waves don't move matter, they actually need to have their own term for how they progress from one spot to the next spot. And that term is propagation. I say that waves propagate, meaning they go from one spot to another spot. That is the equivalent to a wave moving. We had this term from oscillation, we have a new term when we talk about waves. When objects oscillate, we had amplitude, right? We had an equilibrium position. Here we have to talk about wavelength, because if the oscillation is moving across some distance, it is still repeating itself, but as it repeats itself, it changes its position, right? So it's repeating itself here, now it's repeating itself over there. In the time that it was moving, it makes one full oscillation. It goes through what is referred to as a wavelength. That's the distance a wave travels before it completes one full oscillation. And we'll show this on a diagram in just a moment. Another variable that we have to talk about is amplitude. Amplitude is the displacement of the medium that it undergoes while it's from its resting position. This is the same definition we had when we looked at simple harmonic motion and oscillations. The only difference is now the waves that are moving oscillations, they still have that same sort of amplitude. It's just that amplitude is moving with the wave. And again, just like the amplitudes with oscillations, the energy that's contained within the wave, it is proportional to the amplitude. So we have wavelength, the distance between two identical points on the wave. We have amplitude. And here we have a diagram that shows this very well. Here we have a wavelength, you can see right here. It's a difference from crest to crest. We have amplitude shown here. And then if we have a wave that has a high point and a low point, we'll term the high point a crest and the low point a trough. Now, when you were in class, you did pick up a worksheet called the Drawing Waves worksheet. So you have a Drawing Waves practice. I would like you to take that out, and I'm going to go through and show you how to draw a wave with wavelength and amplitude. And this one's going to be 1 meter of wavelength, 1 meter of amplitude. So take that out, follow along, and then I'll have you do a little practice before we carry on with the rest of our notes.